Bacteria on the International Space Station are mutating and gaining strength. Astronauts on the International Space Station, ISS, are not alone. With them orbiting the planet is a whole menagerie of microorganisms that got on board with astronauts or supplies from Earth. In a recent study, a team of experts took a closer look at some of them. Scientists have discovered that these microorganisms have mutated and are now genetically and functionally different from their terrestrial counterparts. It might seem that the interior of the International Space Station is an immaculately clean and aseptic environment. Nothing could be further from the truth. Wherever there are people, there are also microorganisms associated with us. The ISS environment is characterized by elevated CO2 levels and microgravity, but this does not bother the microorganisms. Moreover, the lack of competition from microbes normally found on Earth favors their development. Some of the microorganisms living on the ISS may potentially pose a threat to the health of astronauts. Which is why NASA commissioned a list of microorganisms on board the ISS a few years ago. These studies have revealed an astonishing number of them, although their impact on astronauts' health is not entirely clear. NASA and other space agencies are interested in determining what microbes and in what quantities occur on the International Space Station and how the station's microbiome changes over time. Knowing this population can help develop safety measures, especially in the case of planned long-duration space missions, such as those to Mars. Since its inception in 1998, the International Space Station has hosted nearly 300 astronauts. Along with them and cargo transports, various microbes entered the ISS. They form a unique community. And because they can evolve quite quickly, they are different from their Earth counterparts. In a recent study, the results of which were published in the journal Microbiome, scientists looked at strains of the Enterobacter bugundensis bacteria. It is an opportunistic pathogen that causes various infections, such as endocarditis, bacteremia, osteomyelitis and septic arthritis. This species also has high adaptability and is resistant to several antibiotics. Scientists obtained 13 strains of this species of bacteria from the International Space Station for analysis. They found that Enterobacter bugundensis on board the ISS was mutating, becoming even more resistant to treatment. Moreover, it coexists with several other microorganisms and may even help them survive. This behavior in a microgravity environment may lead to the dominance of Enterobacter bugundensis on board the International Space Station. Researchers' analyses suggest that under the influence of the unique environment of the ISS, these bacteria have mutated in many ways and are now genetically and functionally different from the Enterobacter bugundensis we encounter on Earth. Our research identified certain genes that are present only in organisms on the ISS, but not in their terrestrial counterparts, the authors wrote in the publication. Understanding the evolution of bacteria in space is important for protecting the health of astronauts as well as developing alternative approaches to combat pathogens. For these newly evolved strains, their adaptation to microgravity may help combat them. The mentioned genes, present only in bacteria with ISS, can potentially serve as targets for therapy against pathogens. Unlike their terrestrial counterparts, ISS strains exhibited resistance mechanisms that classify them in the ESKAPE group of pathogens. This is a collection of drug-resistant bacteria that are able to escape the action of currently available antibiotics. Pathogens from this group are highly virulent and have numerous mechanisms of resistance to antimicrobial drugs, which makes them a serious threat. We uncovered the evolutionary trajectories of key genes, especially those contributing to functional adaptations and potential antimicrobial resistance. The key hypothesis for our study was that the unique nature of the space environment, which is different from any environment on Earth, could drive genomic adaptations, the authors admitted in the publication. The Japanese Slim lander continues to amaze. He survived the third moonlit night. The Japan National Space Agency, JAXA, announced that on April 23 it managed to establish communication with the Slim lander. This means that the spacecraft survived the third lunar night. The Japanese lander Slim, Smart Lander for Investing Moon, survived its third night on the Moon, JAXA reported. On April 23, the probe responded to a signal from Earth, sending a confirmation photo of the area in which it was located. Slim landed on the Moon on January 19 this year. The fact that it is still working after more than 3 months is a huge achievement of Japanese engineers. The main task of Slim was to demonstrate precision landing technology, which is why the lander was also referred to as the Lunar Sniper. And it worked. Slim landed on the Moon with an unprecedented accuracy of 55 meters to the previously determined landing site, which is a big step compared to previous attempts, which ended several dozen kilometers from the designated target. The probe had some problems during landing. It landed on the lunar surface in the wrong position, causing its solar panels to fail to generate electricity. This put the rest of the mission into question. However, as the direction of sunlight changed, the equipment regained power. We successfully communicated with #Slim on 04/23, confirming that Slim survived its third night. This is the lunar surface taken by the navigation camera on 04/23. Because this was captured during the earliest moon phase yet, the moon is bright and shadows are short. The probe was not designed and built to survive lunar nights. It has no heating or any special insulation to protect the electronics. And conditions on the Moon are not the easiest. During the lunar day, temperatures on the surface of our natural satellite can reach over 120 degrees Celsius, but at night they drop to -130 degrees Celsius. These are difficult conditions that destroy batteries and electronics, especially since both night and day on the Moon last 14 Earth days. The moonlit night was the cause of death for many robotic missions. Landers usually stop responding after the first lunar night. But the SLIM spacecraft has managed to survive these conditions 3 times now. The original plan was for SLIM to die after the first lunar night. But the Japanese equipment has shown great durability and has already overcome the extreme conditions on the Silver Globe 3 times. JAXA said on social media that key SLIM functions were retained and most instruments were operational despite repeated temperature cycles. The agency said it would closely monitor the lander's condition.
Pas de soleil, 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 pas de soleil.